Welcome to Hitex and welcome to our MDK 6 webinar series, Modern Embedded Development Workflows, starting today with session 1, Modern Code Development with ARM and Keil MDK version 6. I also would like to welcome Trevor Martin from Hitex UK, and I'm happy to have him here once again. My name is Wolfgang Fuller, and I will give you a short introduction about Hitex before the webinar starts. Hitex was established in 1976 as an embedded development company and has achieved rapid growth by developing and providing microcontroller development tools. With a global network, a branch in the UK, and many strategic partnerships, we ensure a presence wherever it is needed. Today, Hitex, as a proven expert, is also in great demand as a service provider for training and consulting, test services, development, and production services. Hitex supports all phases of your project, from the idea to the finished system. With over 70 employees, most of whom are developers and engineers, Hitex has excellent expertise and enjoys an outstanding reputation. Hitex is the preferred design house for all major microcontroller families from Infineon and an important distribution partner for ARM Keil tools and tools for hardware and software testing. The webinar today will be led by Trevor Martin. Trevor, our expert for ARM Cortex development, machine learning, and artificial intelligence. Trevor is not only expert, consultant, and trainer, but has also written a number of books and guides about microcontroller families and development software.
Good morning, everybody. Thank you all for joining us. As Wolfgang said at the beginning, we have a series of webinars where we're going to give you an overview of the new Keil MDK version 6. So this is quite a big change from the previous versions and includes a lot more components and different possible workflows. So today I want to look at the core tool chain and introduce you to the features that are within that. Next week, we'll have a look at the various system components and middleware that are provided by the different versions of MDK 6. And then in the final version, we'll have a look at the functional safety offerings and also the tools, utilities and workflows provided for machine learning development as well. So I assume probably quite a number of you are using Microvision in MDK 5. Just to be very clear, this is part of MDK 6, so you can continue using it with an MDK 6 license. However, it is effectively now end of life, and it's still being maintained. New releases are coming out, but there will be no new features added to Microvision. So you need to consider a move to MDK 6. And that's a bit of a leap initially, so it takes some planning and a bit of exploration of MDK 6 and then move over when you have your next project ready. So MDK 6 itself is based on VS Code, and then there are a number of extensions installed to provide the ARM tools. These you can install through the extension manager within VS Code. But there is a Keil website with the URL at the bottom, and in there's a single box you can click and it will download and install the extension into VS Code. So that's probably the quickest and easiest way to get going. So we're putting in support for a build system, the YAML scripting language, also a couple of debuggers, and additional debugger support as well, along with various items of middleware and software components. So, as I said, the new IDE is based on VS Code, and unlike Microvision, the control elements in here are spread through the overall window of VS Code. So on the left-hand side, we have the side panels. So these allow you to activate different areas of the project to control various activities within the project. In here, the most crucial one is the CMSIS view, which gives you the project view. And then at the top, the various build options and entering into the debugger are activated in this view as well. There's also the control panel at the top where we can enter scripting commands to control VS Code. And then just to the right to that, we can open a chat panel to talk to an external LLM to help us with coding options. And again, we'll discuss that a little bit later. Then over on the top right-hand corner is the button that will take any templated windows and allow you to view those in the a component view. So again, this gives us a drop-down list so we can easily configure hash defines, etc. At the bottom, we have the control command windows. So again, we can see the state of the build system, messages from the debugger here. There's also a serial terminal support when we're in debug mode, and additional support that we can install for operating systems as well. And then at the lower status bar, there are a number of very important windows here. So we can open up licensing, we can set up the tool registry, and also control the project workspace as well. So again, the status bar has access to a number of important options within the project. And then finally, over in the bottom left corner, we can add in our username. So if we want to connect to external services such as version control, we can add in accounts there. And also we can control the features of VS Code. So this normally defaults to a dark mode. Here I've set it into the light mode, so it's a bit easier to view during the webinar. The other important thing about VS Code is that it's available across multiple operating systems, so Windows, Linux, Mac OS as well. So again, you have a tool chain that you can use on any operating system and PC that you want to. So on the left, we have the various different panels. As mentioned, the CMSIS project view is the most important. That will give us a view of the project manager and the build options. At the top, we also have a project explorer. So this will give us a raw view of the project directory. So if we want to get into any of the build files or support files, we can view and edit them within there. There's also source control, so this can connect to any repository that you want to use. It does default to GitHub, and again at the bottom there are additional GitHub panels so that we can view our activity in there in more detail, and we see those again a bit later on. There's also, we can enter the debugger view from here. So this gives us a good run control and view memory type debugger. And as recently introduced, there's also a debug trace view. So we can get a live view of variables, and that will be extended with more trace information in the very near future. When we set a project up, we'll typically select a device and evaluation board, but there's also a device manager here as well, so we can manually set devices and boards when we're within the project. When we first come into microvision, sorry, I keep doing that. When we first come into VS Code, we have the option to create a solution when we're in the CMSIS view. Or we can import a microvision project. So any existing work that you've got can easily be imported into VS Code. And this does work quite well. It tends to set up the project, although you may have to go through and manually set up the debug options that you want. If you have an existing project in the source control view, we can open an existing folder, or we can clone a repository and then start working straight away. When we are starting a new project, we have a simple solution that we can set up. So we select an evaluation board, the target device, and then depending on that device and its support pack, there'll be a range of templates that are available, so we can easily start a well-configured project. And we'll look at some of these today and also over the next couple of days to see how these work in a bit more detail. Also, there's a devices website. So if you are looking and want to see what support there is for a particular processor or evaluation board, these are visible on the Keil website. So we can go through and check exactly what features and the state of the support packs, etc. So within VS Code, when we start a project, the build system that's included is a build system called CMSIS Toolbox. So this is built on top of CMake, but also includes a C solution workflow that manages the packs that are in the system, and versioning of those and downloading of additional support packs that are needed for the full build system. So we have a sort of traditional make system, but then a more custom build system built on top of that as well. So this is invoked via the IDE, but exactly the same build system can be used from the command line. So it's very, very easy to migrate from the IDE to a command line build. So if you're moving into version control system or continuous integration, being able to move over and reproduce the build within that system is very, very straightforward. The CMSIS Toolbox does support a range of compilers, both GCC, other commercial compilers such as IAR, and also the ARM AC6 compiler and the newer LLVM compiler as well. So both of these are available within the toolchain. At the moment, AC6 is probably the most widely used. It's now at the end of development within ARM, but in terms of developing code for Cortex-M based devices, it really does produce the best code density. So at the moment, using AC6 is probably a very good option. Then we have the newer ARM toolchain for embedded, which is a later, more open source, free to use toolchain. And that supports all of the different Cortex architectures, so A, R, and M. And also it has a more flexible front end, which can be used to work with other languages and other utilities, which we'll see in the final webinar. So again, you have a choice of compiler. Personally, I use AC6 at the moment. Again, you may want to migrate from that in the future. There are still quite a few projects that are using the older ARM compiler 5, which again is a very, very good compiler. That doesn't support the licensing mechanism that's within VS Code or the newer toolchain. This is the user-based licensing, but it is available, but you would need the professional version of the tools to be able to license the compiler 5. So again, if you have questions on that, raise that as a question. We have an application note that tells you how to install that compiler. When you are managing the tools, down on the status bar, we can open the registry, and this allows us to select all of the versions of the tools that we want to use. So we can pin those and configure those. There's a couple of things to watch out for here. I have found that when you download some examples to use to build locally, sometimes the tool versions get dropped, so it comes up with a 0 and then nothing works. So you may, a first step when you download a version is to open the ARM registry and make sure you have the versions of the tools that you want selected. Again, sometimes if it's set to an older version of the tools, you also risk the CMSIS Toolbox downloading that version of the compiler and installing it on your PC. So if you're not careful, you can always end up with lots of different parallel versions of the tools as it tries to support what it thinks you want to do. In here as well, we can also open a window to manage the solution. And this gives us a nice flexible environment where we can define the hardware that we want to use and different versions of that hardware, and then different projects to run within run on that hardware as well. So again, we'll see how this can be used a little bit more today and in the future. Then we can also select the debugger and debugger adapter that we want to use here as well. So again, making sure this is all set up correctly, and then we'll be able to build the solution. If there are problems with the project, this section of the status bar will turn red, and if you hover over it, it will give you warnings and errors about the project that makes it easier to resolve. Also on here we have the license management. So now when we install the extensions, there is a default community license that gives you pretty much full access to the tool chain, so you can try everything out. From there, to use it commercially, there's an essentials license which gives you the bulk of the tools that you need, or a professional license that mainly adds things like the functional safety components as well. And again, we'll discuss those and go over those versions later on. When we are working in VS Code, our first stop is the project view. So this gives us a view very similar to existing Microvision projects, if you're familiar with those. So again, we have the runtime editor that allows us to configure the different components in our platform. We have a new addition to the linker script file, which is a regions header file that allows us to graphically set up the memory regions for the ROM and the RAM that are on our device. And also we have support for code generators that are provided by third parties. So here we have the SD cube that we can run from within VS Code as well. If again at the top, if we want a more general view, if we select the Explorer view, that will just give us a raw view where we can go in and have a look at the underlying build files or any other script files that we want to manage. Within the RTE, this works very much the same way as we've been used to within Microvision, that when we install a software pack, any software component will appear here, and then we can select it and add it to our project. And it is, however, a little bit more flexible than what we're used to within Microvision. So here, within our project on the left-hand side here, we have a support board layer. So this defines a pre-configured section of our project. So for example, a board support package that would define, for example, the pinout, the CMSIS drivers, and the board GUI, the board's driver, board support package. So that can be installed into our project, and then we can build our own application code on top of that. So here the RTE can now appear both within our section of the project and also within the board support section of the project as well. So within the RTE, there's an additional drop-down box that allows us to select the layer that we want to work with, and then we can manage those components. One slight side effect here is that if you have a component that's in a different layer, you may not be able to edit it unless that layer is active. So that can be a bit frustrating until you realize that something won't untick or can't be checked until you select the appropriate layer. So again, do watch out for that. Also, when we're working with these packs, a good first step when you download a project and start to work with it is to open the build menu, and in here there's an option to refresh the software packs. So this will update everything, make sure all of the packs are correctly configured, and then you can do a build. And this will often sort out any teething troubles to get going with an example that's been on the internet for a little while. Within this option, we can also do a clean and a rebuild as well. When we are working with Cube, it's very important that we open the code generator from within VS Code. So within the project, if we've added Cube as a component, we can then launch it from the project menu. We can then configure all of the options that we want within Cube, and then we can generate the code, and then that project is loaded back into VS Code within the pack system. So this means that doing things this way links the two tools together. If you start the Cube, generate a project, and then open it in VS Code, it really won't be properly configured to work with the pack system. So it's very important to start the code generator from within VS Code. The same with Microvision as well. Start it from within Microvision, and then the two tools work together in a much better way. You may find also that some options within Cube may be pre-selected, particularly their middleware. Often it's a good move to uncheck these and then just import the raw configuration and then add components that you want to use from within the RTE within VS Code. When we are working with devices, you have these different device family packs. Increasingly, the CMSIS Toolbox build will download those and integrate them as required. They are available on the Keil website. So again, we can download them as a straightforward pack and then install that locally. Or we can use the utilities that are within CMSIS Toolbox, so cpackage get, so we can run that as a command line to install it. So again, there's a number of ways of managing that. And if you're used to the pack installer that's within Microvision, it's still possible to use that as well. And both Microvision and VS Code are configured to use the same pack repository. So if you're using Microvision and VS Code, you don't have to maintain two separate pack repositories. However, an important thing about software packs is that the newer versions are really cleaned up and designed to work with MDK6. So again, to get the best experience out of MDK6, you need to make sure that the device and the pack that you're using is probably produced about the end of October 2024. So anything older than that really is only designed to work with MDK5, but the newer packs have things like the board layer descriptions and are cleaned up. Some examples and things are removed so that they work better within MDK6. So again, check the pack version to make sure that again, you have a device that's going to work well for you. When we have imported our project into MDK6, many of the software components that we add will have a wizard viewer. So this is a templated version of a header file. So if we click the wizard view in the top right of the screen, it will give us a drop-down box here. Again, this is very similar to Microvision, but it's also been extended to some of the build files that are within MDK6 as well. So again, increasingly, this sort of view will start to appear as standard within MDK6. When we are working with pre-configured with components, they may also add various code templates into the project as well. So if we go to the menu where we can add a new file, at the bottom we can also view the selection of code templates as well. So I think this was in Microvision, but I think it was a feature that a lot of people missed. So down here, if you look at the templates, you can add sort of skeleton code, helper functions very easily into your project. So again, keep an eye out for that as well. The linker script files were a bit anarchic. So depending on the different support or different silicon vendor, we had different styles of script file. This is now being standardized. So we have a memory regions view. And again, this is templated, so we can more easily set the base address and size of the code and ROM regions that we want to allocate, and control the stack and heap size as well. So again, this will start to find its way through into many of the examples and projects. So within the C build system, as we create a project, it will automatically create a C solution and a C pack file. Depending on the software packs we're using, we also get the option to use these layer files, these pre-configured files, and these are all then used within the C build system to generate the code. And again, that, as I said, can migrate out to command line again very, very easily. All of this is in a YAML scripting language, again, so it's human readable, so we can go in and extend and change any of the build options that we want. Within the CMSIS build view, as I mentioned, we can have a number of different layer views. So as we import our software packs, they come with layer files that define software layers for different evaluation boards, and we can migrate from those to our custom hardware. So these layer options give us a way to improve our workflow, that we can write our application code to access a standard API, and for example, CMSIS drivers, and then talk through the board layer to the drivers that are on the evaluation board. We can then have a separate board layer for our production hardware, and then switch over to that board layer and rebuild the code very easily. So this gives us a nice way of migrating off evaluation boards to custom hardware without having to manage lots of different changes within our code. And the extension of this is to be able to build software testing hardware that can run on a hardware board. But as we saw in the last screen, we can then swap this board layer for a simulation layer that supports the same API, and then we can write software tests so that we can do extensive testing in software. So again, this works very well with continuous integration systems and extensive testing, so we can create multiple instances of the simulation and run lots of tests overnight, for example. So this layer system is giving us increasing flexibility in how we build code, how we migrate it across hardware, how we use simulation, and also how we reuse code as well. Because again, if we have a common API like the CMSIS drivers, we can then migrate that onto another microcontroller, reuse that code in another design. So the simulation tools that are available within the core tool chain are the ARM virtual hardware. So this provides us simulators for all of the Cortex-M processors, and these are extended with various streaming interfaces. So here we have the simulation code, and then we have a virtual interface. So we have virtual interfaces for I/O, for buttons, LEDs, but there's also a streaming interface for sensors and other external peripherals, and these connect to Python scripts that allow us to stream data in and out, so we can test algorithms within simulation. Also, the virtual hardware has a TCP/IP socket, so again we can connect up to the cloud, to IoT platforms, and also a file system, so we can connect to the PC file system to open, write results of tests, or load in test data, for example. So this virtual hardware gives us kind of a generalized microcontroller that we can use to simulate for testing many of our software components. Again, within the MDK 6 and VS Code, there is a debugger. And as I mentioned before, this currently gives us pretty much a run-stop debugger. So we can set breakpoints, single step, run, inspect the code, look at variables, look at data within the RAM area of the chip, peripherals, and there's also a nice third-party plugin called RTOS Viewer that gives us access to any operating system that we have running within the code as well. So this supports quite a good range of operating systems, so Keil RTX, FreeRTOS, and also interestingly Zephyr as well. So underneath, however, there are a couple of debug engines. So there is the original ARM debugger, so it's a closed source debugger that was provided as part of the ARM Developer Studio. So this really is being replaced by the open source CMSIS debugger. So this gives us, this is really where I think most of the development effort is being run at the moment. And then new trace features will be introduced in the near future. However, the ARM debugger will remain in the toolkit, and it does support a connection to the ARM virtual hardware as well. So it's possible to connect to the simulation and then debug successfully on that as well. So if you don't have your hardware ready, you can test out some of your core code in simulation before you migrate off to the real hardware. Also, we can launch the Microvision debugger. So that again is a very mature debugger with a lot of advanced trace features. So within Microvision, that you can extend the scripting to invoke the Microvision debugger. One of the new features that's been put in is a live trace view. So in here, when we're within the debugger, we can add expressions to this view, and then as the code runs, we get to see that those variables updating in real time. And again, I believe in here some of the newer trace features, probably things like the event recorder, will be visible within this screen as well. So we have a nice standard debugger, but there's then more real-time, more sophisticated debug features will be introduced. All of these launching of external tools is controlled by two views. So here in the Explorer view, we can see the launch JSON file, which allows us to configure a debugger. Normally this will be set up when we configure the project, but again we can open this to view and change any options in there that we want. And then similarly, the task JSON file allows us to run particular scripts and external tools. So again, if you want to run the simulation effectively on a command line to run a whole set of test scripts and provide a result, we can make that a button within the task JSON file. At the bottom here, we can add our passwords to any external tools. So typically GitHub as a repository is very well integrated into VS Code. So if you have a GitHub repository, you can connect to that very, very easily. And here we can use that as a simple repository. So again, within the source code view, once we've connected to GitHub, we can stage our commits, and then we can push or sync them up to our own repository. And this is again very straightforward, particularly if you're a solo developer. However, if you're working in a team, VS Code also supports some of the more advanced features of GitHub. So we can branch, we can add a new feature, then we can do a pull request to have the code reviewed before we then merge it into the final repository. So these sort of workflows are very, very easy to work with within VS Code. Again, there is also a graph view. So as we make changes to the code, we can walk backwards and actually review and see exactly what happened. Within GitHub, we can also go to Codespaces as well. So here, if we click the code button and select Codespaces, if we have a repository, we can then launch that, which will create a version of VS Code within our browser. This we can install all of the MDK6 extensions and then rebuild our code within the browser version of VS Code. So it's then possible to work remotely or with a remote team, whatever your particular use case is. Again, there are examples for working with a continuous integration pipeline as well. So rather than using a local board farm, these demonstrate how to use the simulation platforms to run test code and then finally do a commit. So there is a template that you can download and experiment with, and then this runs directly within VS Code so that we can manage all of our activity directly, see the results, etc. And this typically uses the Unity test framework that again is available as a pack within the pack system. So also within GitHub, we now have this new thing, CoPilot. So this is a LLM that we can use for coding within VS Code. There is a free version. So the first hit is always free. So you get a monthly allowance that we can use for code completion, which we'll discuss in a moment, but also in the agent mode, which we'll look at in the final webinar. So we have the way that we can use CoPilot is via inline code completion. So as you're typing, it may suggest extensions to the code or several lines of code, which you can then accept by hitting tab. There's also, we can open up a chat panel or an inline chat where you can give it English language instructions about what code you want generated. Then it will go through and build that code for you. This is a skill in how you write the instructions and get it concise so you get exactly what you want out. So it does take a little bit of practice, but it can be a good way to work. And again, if doing in relatively small amounts of code so that you stay in control of the actual code generation. There is various inline support. So as you're going through your code, if there are problems in your code, it can suggest fixes. And again, you can accept those or ignore those. And this is incredibly useful when you're refactoring code. So as you're changing variable names or adjusting the code, it will help you maintain several changes through the code in one go. And again, if you're working in a local file, you can manage that quite easily. Sorry, something I forgot to mention here. In the chat view, there's a little button that says add context. So when you're working with code, the context is the active file. If you want to provide it other files to work from, you can add those through that context button. So then it allows the code generation to work over several files and produce additional code. Again, if you right click, there are various options for using CoPilot. So here we can document the code where it'll add a commenting header to the code. And if you have somebody else's code, you can highlight it and ask it to explain the code as well. And it will go through then a description to help you understand the code. Again, both of these are good time-saving additions. There is an option to add tests if we right click. However, I find it much better to use the chat window because then you can describe more fully what you want and the test framework to use. So you can say using Unity tests, creating these test functions, etc. So this again does help you generate the test framework. Even if you go in and edit the values after that, again, it's still quite a fast way of working. So again, this is a big step forward. It does take some practice to get used to lots of autonomous things happening within the IDE. There's also a code review. So again, this is useful to do a machine code review prior to a human code review. So it will go through, analyze your code, and then provide suggestions. And again, you can click through, accept those or reject them. It's a bit repetitive in what it suggests, but is a useful thing to do, but obviously doesn't replace a human code review. But if you're a solo developer, it is a good way to get another pair of eyes on your code. So finally, all of these tools are managed by an external system called Artifactory. So this automates the delivery of the tools so that the system gets upgraded, and then through the tool repository, we can decide on the versions that we want. However, you have to be a little careful that this all goes into the vpackage directory. So this can bloat quite considerably. You can have multiple versions of the compiler installed, for example. So you do need to keep an eye on it a little bit, or it'll start to eat your hard disk. So thank you for joining us today. I hope that was useful for you. If you do have any questions, please raise them and we'll come back to you. We have another webinar next week where we'll look at the platform components, so things like the RTOS, how the middleware works. We'll have another look at the layers, but also the IoT building blocks, and I think maybe functional safety. So thank you again for joining us.